Hey guys, Chris here from Team TBD. We're back again with another robot video. This time it's our midterm exam. Now for our midterm exam, we're required to take our robot from the coordinates 10, 10, all the way around our robot arena, back to the coordinates 10, 10. Then we're gonna flip him around, do an S shape through two objects, and finish at the coordinates 70, 40. For this exam, our teacher already ran it, and he got a time of 41 seconds. For us to get a good grade on this exam, we need to get under a time of 41 seconds. And if we are the fastest in the class, we should get theoretically 100%. So I hope you guys enjoy this video and stay tuned for our time.
Hi everyone, Sim here. I'm going to be walking you through what the code you will see later in this video does. Here's a diagram of what the first part of the code is doing. The robot starts at 10 and 10 coordinates, goes around the arena once, and then ends at this dotted green line position, and then turns 90 degrees to complete the first part of the code. After it turns 90 degrees, it will end up in this position. To start the second part of the code, it will turn another 90 degrees to face in the direction that this arrow is facing. It will move forward and start tracking the first cylinder. When it gets to the middle of the two cylinders, it will track the second cylinder, and then move forward, get to 40 and 70 coordinates, and turn 90 degrees to complete its designated path.
Hey everyone, I'm Stefan Mayer. I helped write the code for the robot, and I filmed and timed how fast the robot could go around the designated path. Let's take a look at our fastest time. Holy cow, that was fast. It took our robot 12.9 seconds to complete its route.
We have two sets of codes, one is Blockly and the other is C. I'm going to be explaining the Blockly part and then Tommy will take over the C part. In this code we use 9 functions. The first 3 are our standard 20 millisecond clock and positive edge detects for real time and detecting pulses. In our check forward function we centralize the head servo so that the pingdar can sense how far it is from the wall in front of it. Look left pulses out 2400. In our go forward function, the pingdar faces left the entire time to sense how far it is from the wall to the left of the robot while moving forward. Going into our main function, we have the loop that does the first part of the project, which is doing a lap around the arena tracking the outside walls, starting at coordinates 10 and 10. While the pingdar is further than 12.5 centimeters away from the wall, the robot will continue moving forward. If not, the robot will turn 90 degrees. When the robot completes a lap, it will do a final 90-degree turn to start the second part of the project. Going into our functions for the second part, which is doing an S shape around the cylinders, we have our first cylinder function that tracks the first cylinder that falls to the left of the robot. Similar to tracking the outside walls, this function will pulse out 2400 the entire time so that the pingdar can sense the cylinder. Then we have our look right function which just pulses out 600. We have this to track the second cylinder which falls to the right of the robot. Then we have our second cylinder function which does exactly what the first cylinder function does, but for the second cylinder. Going into the main function for the second part, we have a loop that does the S shape. First, the robot will move forward so that it can sense the first cylinder, then it will track it. When it gets in between the two cylinders, it will start to track the second cylinder. When it's done tracking the second cylinder, it will move forward and get to the coordinates 40 and 70, and then do a 90-degree turn to complete the designated path.
Hello, my name is Tommy Lay and I'm going to be walking you through some of our code for our project.
In this code, we have 5 functions: a 20 millisecond clock, one to detect a positive edge, one to turn the robot 90 degrees, and 2 more that are responsible for tracking around the walls and cylinders of the arena. To complete the wall tracking portion, the program has a function called drive around that has it look left and maintain a 125 millimeter distance from the wall. To have the robot accurately move around the arena, we have it running at distinct time intervals that are stored in an array and incremented by a counter. When the robot is done tracking the walls, another function is called. That function is called track cylinders. This function has the bot turn 180 degrees, move forward, and begin to track the first then second cylinder. To complete the task, the robot stops tracking the cylinders, goes forward, stops, and turns to face forward.